Okay, so we're going to continue with this lesson on adding and subtracting matrices by looking at something called scalar products. So I know some of you saw on the homework that 3 and 4 have coefficients in front of your matrices. All right, so I'm going to show you what to do when you've got numbers in front of your matrices. So here's matrix E. What are the dimensions for matrix E? It's a 2 by 2. All right, now it says that it wants me to multiply matrix E by 2. So what I did was I wrote a 2 in front of my matrix numbers, and I'm going to multiply every number in that matrix by 2. So 4, 0, 2, and 10. So this is 2E. That's called a scalar product. It rescaled the matrix. Questions on a scalar product? All right, so let's do an example that has scalar products in it. So this example 3 says 3R minus P. So I'm going to write down 3R. All right, and when I write down 3R, I'm going to take every number in matrix R and multiply it by 3. So you get 3, 12, negative 6, 9, 0, and 12. I'm going to pause here. Let me know if you're confused about how I got those numbers. Yes, Alondra. Do you see matrix R? Do you see 1, 4, negative 2, 3, 0, 4? Do you see all those numbers? Right here? All these numbers here? That's matrix R. So you take every number in there and multiply it by 3. Okay? Got it? All right, minus P. I'm going to write down matrix P, which is 3, negative 2. Where'd you go, 0? And then 1, 0, 2, negative 1. Everybody still with me? No? Aviana? What's up? I just wrote down P. That's all I did. All right, so equals, can we subtract this? Why? Why can we subtract this? So rows and columns, what are those called? The dimensions. All right, for these, each of them, they are both 3 by 2 matrices. So if they were not both 3 by 2 matrices, I could not subtract them. All right, so all I'm going to do is subtract the ones that are in the same spots. So 3 minus 3, 0. 12 minus negative 2, 14, right? Subtracting a negative is really just addition. All right, negative 6 minus 1, negative 7. 9 minus 0 is 9. 0 minus 2, negative 2. And 12 minus negative 1 is a positive 13, my B. Aviana. I'm done.
I was going to say, I said it have to be, both 3 by 2, right?
Yes.
So let's say one wasn't, we'll just say no possible.
Not possible. Yes, so if you're doing any problem today with adding and subtracting, even if I throw in a scalar product, if they don't have the same dimensions, it's not possible, right? And scalar products don't change the dimensions, right? The dimensions for matrix R was 3 by 2 to start. Multiplying everything by 3 did not change the dimensions, just the numbers inside. Okay, now, one more thing I want to say before I let you guys try these on your own. Camille, you want to listen to this? Great, excellent. So even though I didn't have a number in front of P, which is minus 1P, if I change this to minus 2P, so just to imagine that instead of 1P, it had said 2P. All right, you have an option here. You can either multiply every number in matrix P times 2 and then subtract, or you can multiply every number in matrix P times negative 2 and then add them. I will leave it up to you. So whenever you get minus a number in front of your second one, right, you can treat it as minus 2P, like the negatives with the 2, or you can treat it as it's 2 times p, and then you subtract. So if you distribute the negative with it, make sure you use addition. Don't subtract again. If you're still confused, just multiply by the positive and then subtract.
Wait. So, you multiply everything by 2.
Then you would subtract.
Subtract by what?
Well, you'd subtract 3r minus 2p. Those numbers. I'm saying some students, Clarissa, yeah, right, 3 minus, it'd be, what, 6?
Well, whatever says plus something.
Well, if it says plus 2p, bless you, I don't think that's going to be an issue. You just multiply by 2 and then add. What I'm saying, students have trouble sometimes with subtraction. All right, if you'd rather add, then just distribute the negative with the number. If you multiply everything by negative 2, then you can add them together. That's just algebra. Everybody good? This is